Hello, and welcome to another edition of Code Remix Weekly. We're your usual hosts, Tim and Sam. He's Tim, I'm Sam. If you couldn't tell from the labels, I know we have some audio-only listeners who treat this like a podcast, so I feel like it's helpful to mention that, don't you think? How you doing
Yeah,
today, Tim?
I'm doing well, thanks. Good to be back home and be able to, I don't know, not have Kevin fill in for me and ever so slightly make fun of my accents. Yeah, we'll
Yeah,
see.
someone's commented that Tim looks different this week.
Yeah. Is it
Just a
more
little.
handsome? Better coiffed? I don't know.
I mean, Kevin does have great hair, though. I mean, Tim.
Yeah.
Oh, hey, hello from San Diego. Yeah, hello from
I
Seattle. So
Well,
where
yeah,
were you, Tim?
I was out in Sweden for a whole week, and then we were attending the JFocus conference Monday
Yeah, how
through
did it
Wednesday.
go?
Yeah, pretty good. And did a full day workshop, like two workshops back to back on helpfully the same topic. So I could
I saw
do a
the
morning
AI
practice run.
generated portrait that you had for JFocus on the website. You looked very much like a Viking, shirtless, rippling muscles, axe, loincloth kind of thing. Is that how you were dressed in real life? I have to imagine that it is.
I had about like 2 months or so to grow my hair out, but it didn't quite work to match the look that I had. But
Yeah, yeah.
still
But
had
the
fun.
rippling muscles, 100% authentic.
Absolutely, absolutely. Underneath this
Absolutely.
this modest blue T-shirt, it is all muscle. Yeah,
Yeah, if only you flexed, it would explode from your body in tatters, and it would be difficult to get you a new one, so we don't want to do that.
yeah, yeah. So yeah. No. And then following that, I took 4 days off, which is like unknown to me. Like
Nice, dude. What did you do?
there was a speaker on conference, so we had fun
Oh,
doing
wait.
networking.
Hold on. Your recovery and time off from a conference was to go to a conference? Is that what you just said? I
Yep,
don't know if you know what
yep.
time off means.
I struggle with the concept, but this at least made me not unease with like not having anything to do and then starting to do open source development. So this was,
Well, I'm glad you had a good time.
yes, thanks. But I must admit that the conference sessions were only half a day. So I was at a conference for half a day, and the other half of it was spent in like a wellness resort kind of.
That
Alternate
sounds
between
nice.
the sauna, alternate and rolling around in the snow, then going into a pool and relaxing a bit. So that was pretty good. Yeah.
That sounds nice. And it sounds like something that attendees of this year's Code Remix Summit in Miami will be able to do, since that hotel is right on the ocean, has several pools, and it has a surf machine, like something that
Oh,
generates a
yeah.
standing wave, and you have a surfboard and can balance on it. And I didn't get to try that last year, but I think I will hope to have a chance to try that this year. I've always thought that surfing looked like fun and never really had the chance to practice it enough to like get on the
No.
board and like stay on the board. I took a snowboarding lesson once from a guy who had been a surfer before he moved to a cold mountainous area rather than a warm beachy area, and he said that snowboarding and surfing were basically opposites of each other. Because like in snowboarding, wherever you put your weight, that becomes your downhill foot, right? So if you lean
Yeah.
back, your feet are going to pivot around, and that's going to be your new front foot real fast. Whereas in surfing, it's the opposite. You know, your back foot is the one where your board is most in contact with the wave. So I thought that was neat, and I'd
Yeah.
like to experience that for myself at some point.
That retroactively explains a lot of the wipeouts I had when surfing, where my skills didn't quite translate as well.
Didn't transfer quite the way you'd hoped they
No,
would.
I'll keep
Right
this
on.
in
Well, there's
mind. Yeah.
well, it's always fun to have something new to learn, huh? So, what are our
Yeah.
announcements for this week, Tim?
So we did as always, our release schedule is every 2 weeks unless Tim is traveling. Yeah, so I'm back. So we did a new release. So that's good. And very new is our support now for a parser for both Python 2 and 3. We already had a Python partner for 3 merged earlier, but 2 has been added as well. And then also we're adding recipes to like backfill the upgrades that you might want to be doing there, adding recipes for, let's say, your LangChain upgrades, not the LangChain for J, but the LangChain originally in Python that you can now upgrade through recipes. So that's been a lot of fun to work out, see how that works, see how the skills we have in recipe authoring translate to the new concepts with Python. And then, we hope that you'll all be able to try those out shortly. So that is one part is new. I've been teasing out my Docker parser for, I think, the better part of a couple of months now, and I can say that it's finally made it into a release, and the recipes are out there for you all to get feedback on. I'll stop here because I might be boring some folks by now. And then there's some other releases as well. So the folks who are maybe not on the very cutting edge, but are still looking to move away from struts 1 to 2 to 5 to 6 to 7, those now have recipes. And similarly, Droppers is still a thing, and there is a version 5 that you can now migrate to. So that's the high-level summary of the release that we did. But there's also a ton of fixes that have gone in, because it has been 3 weeks, and there has been a lot of small improvements, maybe to the way that Maven and Gradle changes propagate when you change a parent POM, those kind of things. And all of that is, of course, captured in our release notes if you want to see more detail. So that's the release, mostly. Then I had one quick tab for folks interested to know, like, what can you now do with the Docker recipes that we have? So most of the folks are going to be interested in changing that first line, the from that you have in a Docker file, swapping out a base image. And then helpfully, we also do this already when it comes to upgrading your Java versions. So I'm not sure if we're listing that usage here, but if you just run your regular Java upgrades and you had a Docker file in there and it was using a certain version of a base image, we're now going to bump that as well. So no need to think about any of that. You'll just see that pop up on your next Java upgrade. So then beyond that, we have a couple of new things, like there's a new training coming up. There's one next week on using AI to write better open rewrite recipes. So if you're looking to register for that one, visit our training hub. And then also we have the advanced training to follow on from the, the fundamentals training that we did yesterday. So for folks who are looking to get into that one, register for the March 24th edition there. Now, I'm told that you have another week to register for the Code Remix with the discounted ticket prices there. So if you want to join us in Miami for maybe surfing, maybe some surfing conferences, I find the best way to take some time off is to go to a conference, see some friends, and see you all there. And then finally, we have a new blog out for something that we're very excited about. There'll be more updates to come on this topic, but if you want to know how we can use technologies that we have, both to analyze our code and then from them extract the information and then distribute that information, then have a look at this blog on Prethink. It's something, like I said, I think we'll feature it soon-ish on an episode, and then we'll be anxious to tell you more about all of that. So that's it then in terms of updates that I had prepped for this week. Unless you had any memes you wanted to share or anything else that you
not this week. I haven't prepared a list this week. So let's get right to bringing on our guest Merlin. Welcome to the program, Merlin. How you doing, buddy?
Oh, good. It's been a long day. So since similar to Tim, I was at JFocus. Now Tim took the weekend off. I traveled to Munich for the next conference. So happy to be back. Hopefully the conference Wi-Fi will work all the session long. I'm positive.
I like the subtlety of Tim went home and you had to go to a conference. It's not like I didn't offer to join you there in manning the booth. And all. You said I wasn't necessary, so now I'm home and I'm getting these live on air kind of venting coming.
It's a real level of passive aggression to be like, no, you don't need to join me, and then be like, you didn't join me.
All good.
But good to see you again. Yeah.
I feel a little bit like I've just witnessed a bit of a spat between a couple who's been married for 10 years and maybe 5 years too long. So yeah, how's it going, Merlin? You're here to talk to us today about how to run 100,000 rules in parallel on Java with Java 21.
Yeah.
Go ahead.
Yeah. So this is basically something I work on a side project. So you maybe know if I'm not working on recipes or recipes tool, examine your architecture and your coupling. I'm enjoying a lot of new Java features. So, the very first recipe I contributed to Open Rewrite was local variable type inference, which is a rabbit hole in themselves.
For sure.
Because I left that one because we definitely dug it out deep enough, I decided, hey, let's find the next rabbit hole. There's always another one. And this time it is virtual threads, structured concurrency, and all the stuff around it that is introduced lately since Java, starting with Java 21. And it will be a lot more prominent here. And the API feels different. They feel different for a reason, for a good reason, because the concurrency we currently know in Java isn't proper for the current throughput applications that we have. And it is changing a little bit, a lot with good purpose there and thoughtful. So you need to get in touch with the API as early as possible so that you don't get scared away early. And
one thing I've been a little bit curious about is what's the structured part of structured concurrency mean? Just that it's more opinionated than new up a thread and have at it? Or does that mean something specific?
So there are two things. So structured concurrency, first of all, is a theory in theoretical informatics. They borrowed the term there. Because structured concurrency is a mathematical provable way of doing stuff concurrently. It has less to do with the implementation of Java is probably grounded on that mathematical work there, but the structured concurrency of Java is more that you have this given structure. Beforehand we had a kind of a structure, but the structure was not that strict. If you think about you can spawn threads as long as you want and access instance variables of a thread as long as you have a reference to a thread. Not a great idea. No structure at all. Executors and completable futures try to put something on there, but
make it a little. So when one is using these structured oh my God, can't talk. When one is using these structured concurrency patterns, you're less likely to run into problems with deadlocks or with race conditions or all of the above, or
structure is really more about the understandability and the traceability. It is, if you're looking at different features in the New York Times, so records, for example, or the local variable type inference stuff, or the on-ramp features, so you don't need the class just to have a main anymore. You have module imports now. You can now use IO instead of system out.println, for example. All of this is to shrink the number of characters. Structured concurrency is the other way around. So it is not shrinking the number of characters there. It looks a little bit bloated at first.
Okay.
But this is because it is enforcing you to think about the scope of a certain unit of work, the scope of a shared concurrently accessed variable, the scope of something that is probably initialized lazily. And as you might know, all the workers and stuff are often used together with lambdas, and lambdas by design are very bad at exception handling. And therefore, completable futures are per design very bad at exception handling. Ever tried to find out why a computable future failed? Nearly impossible without a heap dump, and even then, it's hard to tell. And with structured concurrency, you get the enforced structure of you need to have an explicit handling there. It looks more of a boast, more to read, but here they optimized not for I have to type less. They optimized for I have to understand that one in 1 week, 1 month, 10 years, probably 25 years if I look at some of our some of our enterprise own standing systems, it's
For sure.
not unlikely that we access this code with Java 30, 40, 50, whatever in 25 years.
I mean, we're still fiddling around with COBOL and other mainframe technologies. However many decades later, there's enough Java in the world now that I think it's a pretty safe assumption that so long as there's still electricity in 30 years, there will still be Java
And COBOL.
and COBOL.
Of
Yeah,
course.
it's not going away either.
We just did a new release of the rewrite Cobalt today, so that's
We did.
says
We
something
did.
to the longevity. Yeah.
Absolutely. So, do you have some examples of this to show us, Merlin?
Yeah.
Like code samples, or
Yeah, we have code samples. I would say, because I have a slide deck that we used at JFocus. I would firstly, real quick, not in the depth of JFocus,
sure.
go along there, and then we can focus on something more code heavily, because not everything there is.
And just following up on my question about structured concurrency before you get more fully into your talk, and I derail you later when it's more problematic. I'm familiar with like Go routines in Go and coroutines in Kotlin and some other similar languages. How does this compare to some of those patterns for doing concurrency? Are those also structured concurrency or not?
So in the end, as far I understood it, so I skipped the exam on concurrency where they did structured concurrency, because in the end I decided, well, that's way too complex here.
You're here for the practice, not so much the theory.
Yes.
I got you.
But it helped to understand that all these things there, which are not async await, are kind of this structured concurrency stuff. And they're all about managing resources, giving up your computation time for somebody else, something that our current Java lang threads are not that great at, but now that we have the ability with virtual threads, it is there. So it is similar, but it's definitely a different way of implementing there, because coroutines, they are very short in syntax. I'm not aware of the error handling there, to be honest. But they're very short in syntax there. That's the complete difference for Java. Java took the verbose way, I think for a good reason. So Adam Bean had an interesting point on JFocus there about the verbosity of Java and the verbosity of the language specification of Java and the mathematical proofness of Java and the Java language specification. This is the perfect ground for AI models, because the specification is on, specification is mathematically provable, and Java is very verbose, but very verbose in we have just one way to express this. We don't have 5 ways to express the same thing like Scala and sometimes Kotlin has. We have one type of how do I make a class not extendable. It's make it final. Boom. No, we have a data class, we have a data object, we have a whatever you call it. Yeah.
All right, well, fair enough.
So probably we start really quick. So I think the problem here is, this is the standard problem there. Everybody sees the problem there, especially if we add this one there. No one would ever write that one, to be honest. But if you imagine a Black Friday situation, or one of our workers down there spawning a new thread, probably someone decided, hey, that would be a cool thing. This is a resource consuming task that we are doing here. And now we have no longer 10 users or 100, you have 1 million. Boom, you're spawning 100 platform threads there. Everybody knows that 100 open operating system threads there is a good thing. 1,000, probably think again about it. 1 million, not a great idea to do this, even on an up-to-date Mac there. So what's the point that Java helps us with? So Java dig up a topic that they had at Java 1 point something, 1.2 I think it was, that they thought about something like, we don't need the platform thread, we need something different, and they called it fiber back then. They disposed it because they decided, no, we don't need that. We have applications with a couple of hundreds users concurrently. We have big mainframe systems. They can handle that one. We don't need that one. But the problem is that the platform threads, they're mirroring the exact information like the operating system, and that makes them very heavy because you have 1 megabyte roughly of data at the operating system, 1 megabyte on the heap of the JVM. You are limited to the maximum amount of threads of the operating system. You need around 1 millisecond of creation time, a little bit faster on newer machines, but you need a lot of time there because it is a kernel call. So you have all the security in place to create a thread there. For virtual thread, the idea is, hey, let's not do that. Let's do the scheduling in the JVM and deal with our own. Why not do that? Decouple that one. And turns out that the JVM, just for scheduling, doesn't need this much data. It's just 1 kilobyte. You can handle easily a lot of virtual threads there because the JVM is just another object. And it's created really fast because the operating system is not involved. So you're up to 1,000 times less memory in use. You have 100 plus times more threads possible and 1,000 times less. So the numbers are, some of them are from the JEPs, some of them from the official documentations there. So they made their math there. And it's very easy to think about that once that you can have 1 million plus on a desktop laptop, on an old laptop, you can have 10 millions, 20 millions parallel threads on a big machine back then. And that makes it like, we don't have to discuss anymore if we need a new thread here. Just spawn it. Don't discuss this anymore. Do it concurrently. But that imposes a little another problem there, because if you do break this paradigm of only create a new thread when you really, really need it, to we always create a new thread whenever we do something that is not synchronously, then you have to think about a lot of new technology there. So a lot of known habits doesn't work anymore for the JVM, and that's what the new JEPs are about. The example I will use from now on is this rule engine here. Rule engines are very basic. They're very easy. It's basically a class that defines an interface. Interface rule. A rule can be activated, similar to a recipe or so. And a rule engine just gets a number of rules and some data and executes it again. You can do all of that serially, but if you design the rules correctly, it's more efficient to do them in parallel, especially if you have waiting in place, like I have to wait for a service to answer, I have to wait for a database, I have to read a file, or whatever. If you want to see the final version there's GitHub gist online that I'm updating for over, I think, roughly a year now. Started with Java 23 and now is updated just now to Java 26 preview features, so properly up to date. And the first thing we want to dive into here is virtual threads, possibly. They are not really new. They are Java 21 final features of virtual threads are there. You already learned you can create a lot of them now, why they are created, because a thread follows this graph on the left. The thread is new when it is created. When we call the start method, it is runnable and can be activated for running. And then it could be blocking or terminated. And blocking is always when it is waiting for something, for another service to answer, for a database, for reading something. But the problem here is that in Java, the Java long thread is tied to the operating system thread. So every time the thread on the JVM is blocked because it is waiting for another service to answer, the operating system thread is blocked. And therefore, we are throttling and blocking the resources of our operating system, and probably throttling not only our application, but blocking other applications there as well. We already have a workaround there in Java. It's a fixed thread pool so that we don't create 1,000,000 threads anymore. We create 100, which is manageable. But then we have starvation there because one runnable, only when it is terminated, it will free the platform thread again and get them assigned there. Keep this well-known pattern of executors in mind while we progress. It will come back later in a similar manner. Virtual threads are there to help us. As I said, virtual threads are decoupling the Java threads from the platform threads, and therefore it is easy to start 1,000,000 threads there. No worries there. We can see it in an example later if we have time there. And the JEP itself, the change on the API level is very minimal. So the class thread now gets a factory method, start virtual thread. That's one method there. And the executors just got a new executor, new virtual thread per task executor. So every time we submit something, we create a new thread there, a virtual one, and get that executed. JVM deals with the scheduling there. In the end, down in the JVM, it took the JVM core team a lot of time to rebuild everything there because the change there is very, very, very crucial because it's breaking something that is there since Java 1.0. And it is the coupling between, you see that below, the coupling between platform thread and operating system thread. We saw that before. It now introduces the virtual thread on the left, and the virtual thread are loosely coupled. The JVM can assign them to a carrier thread that is mirroring the real operating system there. And whenever a virtual thread get blocked, the JVM decides, okay, dear virtual thread, you go down on the waiting queue of the scheduler. I select the next one, assign it to the carrier thread in the same carrier thread. Without rescheduling of the operating system, just carry on with the next work to do there. The interesting thing here, internally, the JVM developers choose a well-known pattern. They use a fork join pool to manage a good amount of carrier threads there, educated, selected one based on the operating system, the available cores. And there are some heuristics there to not overwhelm the underlying operating system. So what we see here is that virtual threads are not very different from our well-known executor implementations with a fixed thread pool size. But the thing here is that virtual threads are so deeply baked into the JVM that there are heuristics around there regarding scheduling, regarding resources, that this opens opportunities to further optimize the memory footprint in a concurrent situation. We will come there real short in a minute. Just one point: when you should use virtual threads, because I find it very important to think about if your application is appropriate one for virtual threads. Virtual threads are great if you have an I/O bound operation in your system. So, for example, a database access, a REST access, reading files and writing files. If you have a high number of concurrency, so everything of 1,000 concurrent tasks upwards, or if your web service, if you're thinking about, hey, I don't want to deal with scheduling anymore, I just say, okay, I get a request, here's a new thread, do with it whatever you want. So if you look at the numbers, I/O bound database, REST, file service usages, over 100 concurrent tasks there, you realize that 90 to 99% of our business applications that we write fall into this pattern here. And very, very few ones are to the avoid side. So very CPU intensive calculations like physical calculations or something. These are some applications that are not appropriate for virtual threads there, but they're so low in occurrence that that the JVM developers decided to, okay, we have to go all in on virtual threads because we see that the market is demanding high I/O applications there.
Why is it to be avoided for CPU intensive work or for thread pools? It's not that I don't believe you. I'm just curious, particularly with this all caps never. Why is it so bad to put a virtual thread in a thread pool?
So for that, let's jump one slide back.
Yeah.
And remember this area here.
Mm-hmm.
This carrier thread in the fork join pool.
Mm-hmm.
The fork join pool itself has a scheduler.
Mm-hmm.
Every executor has a scheduler, usually some sort of round robin there. And if you put a thread pool, a caching, a thread pool, additional one here, you're thread pooling the virtual threads with the scheduler, scheduling the threads that are submitted here, that are scheduled, that are again scheduled by the operating system. There's no need to cache them because virtual threads are designed to be not reusable. They are throwaway instances. I create them as long as I need them, and then I throw away. Different to the operating system threads, these are not throwaway resources because they are tied to the operating system and therefore very expensive. So it's more to read, avoid virtual threads if you have CPU intensive calculations and never pool virtual threads. It's not a great idea.
It makes sense to me why you wouldn't want to make a thread pool of something that's already in a thread pool, redundant if nothing else. Why is it bad for CPU intensive calculations?
Virtual threads.
Yes.
It doesn't bring anything. It just adds another.
It just doesn't add anything to it.
Because when do you need scheduling? Scheduling is important if your thread gets blocked. To not block the CPU, you get your thread out of the active execution state to signal the CPU. You can select any other task in your queue. If your thread never gets blocked because it has no IOs, it can never get blocked. It's never waiting on different resources. It is just calculating a big mathematical equation there. Then never gets blocked. Then all the overhead of creating a second scheduler there, creating a second worker there, instantiating another instance of virtual thread. It's a small one, but in creating a new instance there doesn't make sense. There are again then two schedulers where you only need one. You only need the operating system one because you never get blocked in any way. So, but these are just very, very, very rare cases. Usual applications are somehow I/O dominated in their execution time.
Makes sense.
So now that we have virtual threads, this is more of the foundation of the ones that are coming now, is if you have threads and different execution tasks, you want to have data that is shared between threads, and you want to have data that is thread specific. One example here is an SSL context. You don't want to create an SSL context for every thread. You just want to have one SSL context for an application because an SSL context to create is very expensive. There was no good way to share an SSL context in the JVM before. It always was something like, I have no real situation here. If you want to share something, make sure every instance of a thread has an instance of this SSL context. There was something prior that was called thread local, but a thread local was local to a thread. So every time a thread is created, a new instance is created. That's not a problem if your application has 10 threads or so, and every thread has their own SSL context. No problem at all. But if you imagine now we are creating 1 million threads there, so creating 1 million SSL contexts, that become a problem now. Because in SSL context, you don't need multiple of them. You probably just need one of them, and creating multiple ones for additional good amount of milliseconds is not a great idea. That's what scope value help you with. Scope values are value holders similar to optionals. We see that in the API, it's very similar to them. You define a scope value, initialize it once in your scope and say, this scope has this value now, and then all the other threads, all the local threads that are created from this scope on have this value. They're reassignable, but that's a special case there. So the second new API that's already final in Java 25, so available at least half a year and final, is scope values. Scope values are value holders similar to a singleton, very similar in fact, but scope values are baked into the JVM and are flagged especially to the JVM, so the just-in-time compiler knows that this scope values follows a specific semantic of assignment. And the specific semantics of a scope value is the set and path semantics. So we say we have a scope value scope that we open where the scope value SSL context has this value, and the value of context is this one. That's the where calls. And then you call the on now run method. And this run method is a lambda there. In fact, it is runnable. And this run method spawns a new virtual thread. And the virtual thread instance has access to the SSL context and the data context there. And every virtual thread that is spawned inside this scope, even from a child thread there, gets the same scope value reference and gets the same data there. The important thing here is that the instance of SSL context here, they are immutable. The value itself inside there is of course not immutable because we have still in Java, we still have shadow immutability. But you always have this defined semantics everywhere where SSL context, this SSL CTX, get assigned a new value. You have this very specific kind of API call. We open a scope value area where SSL context has a new value here. So that's one part where you see the structured concurrency is we give the assignment of values that are shared across multiple threads a structure where it is very easy to reason about where it is reassigned to which value. Very important if you try to understand concurrent code later. There are some minor differences. So thread local were prior used in a similar way to share data across threads, share multiple similar data to there, but they have some minor differences. So thread locals are mutable, scope values are not mutable. Interestingly, thread locals are not entirely memory safe. At least that's what the JEP said. I never tried to reason that for myself, but it's from the JEP, and so I trust in them.
They probably knew what they were talking about.
Yeah, they probably know better than we know. And also they say thread locals are slower in their implementation instead of scope values, because scope values are in fact just an internal concurrent hash map. Thread locals are, I create a new instance every time. An instance creation is an expensive job to do. The most important difference is that thread locals are automatically recreated for every thread that is created. And because the virtual thread is the same semantically like a normal thread for every local thread for every virtual thread that is created that contains a thread local, a new copy of this is created. And you see where this is going. We're getting, again, a lot of instances created there that we don't need. Scope values, in fact, are designed for virtual threads. They are very lightweight, and they're not created for every thread. They're intended to be shared across thread. But in a structured way, you have this probably, some will say, overly verbose way of reassigning. I say it is a great way to enforce the structure, always the same structure, and enforce best practices by API design. We see this pattern as well in the structure concurrency now. So this feature is called structure concurrency because that deals about concurrent workload. In fact, the other JABs, virtual thread, are the foundation there. Scope values are something that are important for structured handling of data in a concurrent situation. Structure concurrency is not really about the workloads. And think about this, like this Gantt chart, for example. We have an API call, and for one of this API call, we have to calculate an address first, probably not calculate, probably read it from another service and read the full name from a database. And when both of them are done, we can generate a response. For example, give me the address and the information so I can send over, so I can schedule the data, the package sending there.
Hey there, Deshaun. Welcome to the stream. Good to see you. You a structured concurrency fan?
A good point, because now we're at structure concurrency. Here again, the structure concurrency API is not that big, similar small to the stuff there, but the hidden implication and semantics are very good, very important. First of all, it all is about combining to make it explicit and reasonable which units of work belong together. And therefore, we open a scope, a structured task scope. We open it usually by pathing some kind of joiner. We see that later in an example there. And when we have the scope is an auto-closable. And therefore, it is very, very, even SonarQube will help you, and even our recipes will help you to always use this with a try with resource situation. It's very important to see, because now that we have this try with resource, we have this Java language specification enforced of area where the scope, where we can add work to this scope of work. So again, something usually we have a best practice of always create your completable future next to each other. Now we have a language specification grounded way to do this. It is enforced now. How do we submit work there? It is no longer called submit, because we don't submit it to a worker. We fork from the current thread. So we are inside a thread here, and we fork a thread there and assign it this work. Here again is very similar to the executor example and the worker example, how they are called in Spring oftentimes, but it is more likely like, here is the unit of work. Please schedule that for me whenever it makes sense to you. You get back a subtask now. It looks similar to a completable future. A very early draft of this JAB suggested let's take completable future here, but I decided against it because it is something different to have a completable future semantically than have a subtask here. A subtask has a defined semantics inside a structured scope. A subtask has the semantics that once you call on the scope, the join method, so everything that I submitted and forked from this scope is now joined here. This method waits here. It's just blocking. It just blocks the thread gets this post, and it's again a virtual thread here, so no worry here. Once we get back from this method, there's a timeout version as well. Once we get back from the method, we can call the get method here. Interestingly, the interesting point is what is happening when one of these subtasks is failing. Therefore, you have the structured task scope. You can assign policies how to deal with that. So at least one has to be successful, all has to be successful, any has to be successful. And in the end, when you do this, because it is a try with resource and the join throws an interrupted exception, it again, the language specification and the linters enforce you to have this catch block here. And now you see what I mean with the structured concurrency in the end is not only you have the language specification enforced scope of living for the scope. You have one defined point of joining. You also have one defined point of error handling, because all of the exceptions that lead to there are propagated to the catch block there. And now you have a complete, a real dense way of defining a scope of work. Again, it looks way more chatty, way more verbose than in some other languages. But I like my verbose Java, to be honest, because it's enforcing me with these jabs to do it the correct way. Always have a scope there for your task. Never use the scope outside of the scope, so you cannot add something more there, and have a defined point of error handling.
Yeah, it's a really great way to like standardize it in such a way that there's no ambiguity. There's no my colleague likes to write its catch blocks on a different level and then introduce subtle issues with error handling. So yeah, I think the clear readability here is I think the defining feature.
Yeah, so, and once again, we saw that from this progression of the Java language specification development in pattern matching and the switch expression that now enforces you with the compile time error if you do something that is not a great idea. For example, having no default if your switch is not exhaustive. Here we have again the same thing. Here's an exception thrown that is unhandled. Compile time exception. Something that I find very interesting that we quickly have a real fast look there to get YouTube back from your passenger seat is one question I have here is how many SSL contexts do we have here? Or do we get here?
It looks like one, but I'm assuming this is a trick question.
Yes, of course it is. This is a very common way. So I have a class there, I put a final there, and I create something. You see that a lot with logger. This one, because the field is final and just final, it has to be initialized eagerly. So every time the class gets instantiated, we instantiate a new SSL context. So no, not just one SSL context, times of instances, even though it is final. We could do something like this. So that shouldn't be fire, sorry. That should be a get SSL context. That's the perks of altering your slides right before presenting them. You could do something like, I have a SSL context and I have a get SSL context there. So some kind of of just one value holder there with initializer. So I create one if the value is null. That would push the initialization to the point when the SSL context is really needed in the rule, because from the class, from what we see now, the SSL context never has to be initialized. But there's no good way around this. If you want to do it that way with the initialization method to push the initialization to the first use, you have to live with the fact that this field is no longer final. What happens if someone bypasses the get method? What if somebody bypasses, just reassigns the value there after you get the value? You have a dangling reference there. This is a well-known big problem there, but it's getting a bigger problem if you think about we have now 1 million threads there. If they all of them hold a final instance there that are created at instantiation, when you never ever access this value, so it never ever has to be initialized properly, we again have a lot of garbage there that is never used. So they introduced the lazy constants. This is very early a preview feature. So the structure concurrency is in its 6th preview. This one is just a 2nd preview. So very early. They introduced the concepts of lazy constants. And here we are now down to 1 instance per class loader, because the lazy instance is final. You will never have the problem if someone reassigns it. There's no way around it. You only have this one SSL context instance. And because it is static, it is tied to the class. So every class, every instance of this rule will share this SSL context instance. To delay the initialization to the first use, we use this lazy constants here. This lazy constants is a very tiny API. They even shrinked it from the first preview to the 2nd one. You just have the initializer, lazy constants.off, providing an lambda there where you initialize the value. Here we create an instance and throw exceptions if it doesn't work. The point here is that the initializer is only called at the first moment where you call SSL context.get. So even if you spawn up 1 million rules at the same time in your rule system, 1 million instances of that, and it is not created, you don't have 1 million instances, you not even have 1 instance. The moment the first rule decides, now I need an SSL context to call back to another HTTP service, that's the time where the SSL context is created. That's the only time where the SSL context is created. The interesting thing here, this would be kind of possible with the custom implementation as well. The important thing here is that the lazy constant is a JVM and JIT compiler well-known class there. So the JIT compiler treats this SSL context variable similar to the same like a static final variable once it is initialized. So it will unfold every use of the get method there. It will be the direct instance. You will access the direct instance of the SSL context, and you don't need any of the bypassing at all. So that is something that altogether shapes a very interesting future for the future of concurrent Java, if you look at it, from my point.
That's cool.
Yeah, definitely. And it's maybe for someone, for folks that have been following along with JAPS a bit, this of course is now targeted for Java 26 coming out, I think, next month at a Oracle Java 1 conference. And an interesting little tidbit is we often get questions like, can you add support to your parsers for these types of preview features? And oftentimes we kind of push back a bit, like having learned from the string templates that were at one point a preview feature and then dropped again. This one is actually a preview feature in Java 25 already, but it was named differently. It was named stable values back then still. And now what are called lazy constants, which I think more aptly described what it's intended to do. But it also, again, kind of illustrates why we are hesitant to implement these preview features. Because while it would be nice to have you automatically migrate from stable values to lazy constants, it does complicate our parsers quite a bit when we have to, each and every time a new patch version comes out, make the corresponding changes. So
Yeah.
apologies
So
for folks giving a bit
Well,
of
it doesn't
context.
look like there's much new syntax there, so I'd expect that even the old parsers would interpret that correctly. But for those things where there is new syntax, absolutely.
yeah. So most of that, so that will be parsed with our existing parsers. Yes. But to be honest, I wouldn't be surprised if we at least have a new set of traits to visit this kind of scopes. So the scope value scope and the structure concurrency scope there, because they are similar in a kind that you have this concurrency scope there, but they are not just normal scopes. They have different secondary semantics to them. So we might see some not LST changes, but some new traits there to deal with them, because
Yeah, for sure.
they have a lot of hidden semantics there. One thing that I would like to show you, I'm not showing you the recipe run, but I wrote a recipe, of course. I'm a recipe lover, and but I learned from my let's do a recipe that is helping people to adopt var error, and wrote an analysis recipe first. And turns out that I learned quite a bit of detail there. For example, this is the output, the data table that is created of one of my recipes. I can drop the link in a minute there. What it does, it is called find never mutated thread locals. Because as we learned, thread locals and virtual threads. So migrating to virtual threads is easy. Activate and Spring in a configuration, or Micronaut or Quarkus, or just call the new virtual thread per task submitted executor on your executor. It's very easy. The big problem is if you have a library or a shared library in use that uses thread local somewhere for passing along some context information, you might want to migrate to scope values in the end. And for thread locals that are never ever mutated, the migration is quite easy. It's a type change and 2 method changes there. But as you might know, instances can be mutated, and mutation and concurrency is a real bad idea. And so I started a recipe that is finding thread local definitions and assessing their usage with Open Rewrite recipes, which is surprisingly easy, to be honest. And that a recipe, you can run that one that checks if a thread local is never ever mutated. A good candidate for a direct migration there. The second one is thread locals that are mutated only in the defining class. These are no candidates for direct migrations already, because you have my mutations. Scope values are never mutated, so we have to do work there. What's even more, I don't know, there was I surprised from. Basically, Claude in our discussion made me aware of that some people might not hide their thread locals privately. Yes, and surprise, surprise, this is Spring and Netflix. Even in this high-level repositories, we find thread locals that are not private and potentially mutated outside of their defining class.
Yeah,
And
this
that's
is
something where you have to say, stop it here. We are not a candidate for virtual threads yet. We have to do virtual migrations. And in the end, I
Gasp.
I deleted a draft PR to migrate to thread locals because I found out that it's not uncommon.
And
And
this
that's
is why
probably the answer
yeah.
for folks that were hoping for an open rewrite recipe that is moving them all the way to all thread and virtual threads, to all scope values and structured concurrency. Sorry, folks, it's too complex. It's not possible on a generic level. We
It's one of
have
those
to do manual
recipes that would be
migrations.
all edge cases.
Yes. Even here, we can filter them. I think it's 1, 2, 3, 4, 5, 6 instances of 60 instances that can be migrated without manual work. So, sorry, folks, not everything
Oops, all edge
is
cases.
migratable right away. So
Yep.
we don't get
And
workless, so to say.
And this is exactly why we love to write these search recipes first, because it's very easy to think, oh, you can just, it'd be so rare not to be able to convert it. And then it turns out it's very rare to be able to safely convert it. And, lesson learned, and a lot of effort saved by first looking for the thing that you're interested in.
Yeah, definitely. So let me drop to, I think I have the YouTube chat open somewhere. Can I drop here in the chat and it's ending up in the YouTube chat? I don't think so.
It should be.
Private chat. Ah, there we go. Entering. Yes. I want to join YouTube. Yes. 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 Whoops. Okay, it is easier if I switch tabs. Join my own live stream, and here we go.
That works.
There's the recipe artifact, which is public on Maven Central, so you can easily run the recipe just by installing the Maven Gradle plugin. And here we have the gist for everybody that is interested in how it looks in the code. We wasn't able to look into there because, even though we just scratched the very surface of this JAPS, there's a lot more into it. We were just, it's just 1 hour. Sorry, folks.
Well, it's all right to just give the people a taste, and if they're interested, they can pursue further research on their own time. But yeah, great stuff, Merlin. Thanks for coming and educating all of us about structured concurrency, and yeah, pleasure to have you on the program. Do you have any final thoughts or remarks that you want to close off with?
Yeah, get in touch with the APIs. We will not see everything of them. Most of them will be hidden in Spring or Java EE. But get used to the structured concurrency scopes and the scope values, because that's the APIs we will deal with. And always keep in mind, always put in their immutable stuff. Never put in their immutable map, because you will access a hash map concurrently. A hash map is safe in thread locals. A hash map is not safe in scope values. If you have a question why, just reach out on the next conference. We can talk about it another half hour. Why this is not safe.
And much like Tim, you're at conferences basically every other week, so it shouldn't be hard to catch you at the next conference.
Last year it was 12 conference talks, so roughly once a month.
No, I'm pretty close, one per month.
And then
well, with just a little more effort, I'm sure you can double it and be at a conference every other week. All right. Well, thank you so much for joining us on the program, Merlin, and thanks everyone who came and watched. And we will see you next week for another edition of Code Remix Weekly. Tim, do you have any final remarks, any final thoughts before we sign off?
No, just looking forward to next week. It's a topic
go.
I know well and look forward to sharing with you all. So,
all right. Look forward to it.
Yeah.
Thanks a lot, everyone. Bye for now.
Yeah, bye.
Bye-bye.